Hi everyone, today we're going to do something different. We're going to deepen in all the problems that we solved so far. This is a little bit of a contribution that I want to give to your learning process in math. And what we're going to be talking is about the visual representation of inequality, especially the absolute value inequalities that we have been working on so far. I'm going to use the same examples that we have so far, and we're going to reflect them in the XY axis. Okay, starting with the problem 3a that we solved a couple of days ago, and just see the relationship that they have in an XY axis. So to start us, let's do a recall on the solution that we have on that 3a problem, which, if I'm correct, it was the x that belonged to the interval minus 2, 4. That was the analytical solution. Then the graphical representation that we had was that we drew the real line of real numbers from minus infinite to plus infinite. We choose two random slots to just represent the interval minus 2 to 4, and we knew that the solution was all the real numbers that were inside that interval, right? So there is something else to it, okay? There's a relationship between the x-axis and the real line of numbers that we use to represent. And the relationship, the fact is that they're actually the same. The x-axis is in real life the line that contains all the real numbers. So these two that we have on top are functions that we're going to graph. Okay, so we're going to based on absolute value of x minus 1 and just do a quick simple representation of it. If you want to learn more on how to do quick plotting, just follow my videos for quick representation of simple functions. Then we have 3, which is the other function. We're going to graph that on a different color. And the problem then is going to be compare these two functions, absolute value of x minus 1 with 3, and see where they two meet. And then, as you can see in the xy axis, they meet at two precise points, minus 2 and 4. Wow, coincidence, right? Looks like the real points that we want the real line. That's where they meet. See, they intersect, minus 2 and 4. So then the question that the problem is lying is, when is absolute value of x minus 1 less than 3? And it's this area right here. When is the absolute value of x minus 1 smaller than 3, the number 3, the horizontal function 3? And it's this area that we just highlighted. That is the graphical, visual representation of the inequality. It's just a comparison of two functions. Now let's do the other one example. It's going to be the same thing. Just do a quick plotting. Again, please refer to the simple function graphic representation videos that I did. I'm going to post a link on it in the description. Here's absolute value of x plus 1. And now we're going to draw 2, which is the horizontal line. Different color right here. And as you can see, it's going to be the same case as before. It's a comparison of functions. In this case, when is absolute value of x plus 1 greater than 2? And here we are, these 2 points, which coincidentally are the same exact points that were illustrated in our solution before. What was the solution? Minus infinite to minus 3, open, union with 1, open, to infinite, positive. That was the solution that we had before. We did that on the real line numbers, minus infinite plus infinite. Choose two random points to represent minus 3 and 1. And all numbers to the left of minus 3 were part of the solution, as well as all numbers to the right of 1. And once we refer to the original problem, which is comparing absolute value of x plus 1, when is it greater than 2? Well, as you can see, all we have to do is understand graphically, just like we did before, when does that happen in the xy axis? Well, as you can see, it happens here and here. All values left to minus 3 and all values right to 1. That is when the blue function is greater. It's above the orange function. Finally, let's do problem number C. Again, quick plotting. So let's do right here, -1/2, -1. It's going to be a little bit different, the plotting, but it's still going to be simple. So let's do absolute value of 2x plus 1 in blue. Here we go. And same thing, all we have to do is now represent the horizontal line 1 in this case. And then the problem is asking us to compare when is absolute value of 2x plus 1 smaller, less than 1. And as you can see, they intersect, they have 2 points, just like we did before. Remember the solution that we had? Yep, it was all the x that belong to the open interval -1, 0. And surprise, once we see the real line of numbers, plot those 2 points, -1, 0, it was an open interval. Here we go. And if you look at the chart at the xy axis, you will see that it is in those 2 points where the functions intersect, -1 and 0. Therefore, the portion, the area in which absolute value of 2x plus 1 is less than 1 is this one right here. All the area that is covered between -1 and 0. So there you go. Hope you like this video and see you on the next one.